I prepared a small number of slides. So this is session 2, and the session is about benchmarking in the present. But the core issues, as we've discussed in the past couple hours, are many of them new versions of old problems, not just for benchmarking, but actually for every kind of empirical research. So today's benchmarking can learn from the past in sometimes unexpected ways, and maybe even more surprisingly from other disciplines. And of course, in principle, those disciplines could learn from us, although I think for the moment, well, the main thing they can learn from us is the value of large amounts of data. This session's participants, the presentations will be one by Brian MacWhinney and Saturnino on detection of dementia from speech samples. Kiela from Facebook will talk about Dynabench, rethinking benchmarking in AI. Anders will talk about 5 ways to make your data more relevant. And Victor Hansen and Anders will talk about guideline bias. And following the pattern that Ken laid out, we'll ask for brief presentations from each of the 4 speakers or speaker groups, and then discussion and questions. And I wanted to I'll make some general points in advance, but then this will go quickly and we'll turn it over to the speakers. Brian, from Brian's slides, he says more training data is needed despite involvement of 180 labs and a similar number of published papers. Other projects have not been contributing data. And of course, the data problem has many aspects, and this is not a problem just for Dementia Bank and for Alzheimer's benchmarks and so on, but actually for biomedical research in almost all areas in general. The biomedical researchers are roughly 4 decades behind the curve in learning the value of large amounts of data and shared data. But being specific about the neurodegenerative area, the total number of subjects is small. The Pitt Dementia Bank collection is the best that's generally available, but it's just a couple of hundred subjects. The amount of data per subject and task is quite small. The infamous cookie theft picture description averages just about 90 to 100 words per session, a little less for the people with dementia, a little more for the normal subjects. But given Zipf's law, that's not a very, it makes it hard to find the features that you want. There are actually no test batteries in this area that are normed for longitudinal tracking. If you wanted to do serious longitudinal tracking, you would have subjects describing the same picture once a month for 10 years, or retelling the same story over and over again. And obviously, there are going to be practice effects and boredom effects and so on. Also, the standard neuropsychological tasks are quite culturally biased. The cookie theft picture basically shows a 1950s suburban kitchen full of gender stereotypes. None of these issues are new, and they're not limited to clinical HLT applications. And as Brian knows very well, and as he explained, as he will say in his talk, and said in his talk in the last hour, it's part of a much broader discussion about sharing data and replicating results. The second presentation will be on problems with benchmarking, and there's a long list of bullet points: saturation, bias, alignment, leaderboard culture, reproducibility, accessibility, backwards compatibility, and utility. And the main point to make about this is that actually each of these problems can also be a feature as well as a bug, because not everyone cares about the same thing. So, for example, saturation and alignment. Saturation can arise because we want to do something that's very, very hard, and we don't want people to get too discouraged or just to fail completely. So we want a task where there's some headroom, but there's also some possibility of improvement. And the likely result of that is that if we design the task right, after a couple of years, we'll need to change it because it will have saturated anyway. Anders gives 5 reasons, 5 things to do to improve your benchmarks. And as I mentioned in the previous, this is great advice, but as I mentioned in the previous discussion, they're exactly analogous problems in many areas. For example, uncontrolled covariates in lab animal drug testing, where timestamps, researcher demographics, so to speak, and many other issues play a role in the outcome and help explain why sometimes results don't generalize. Guidelines bias, they mention priming effects. We asked different Turkers what movies they like, love, prefer, and the choice of verb there makes a difference in the responses. And order effects, order of goals in conversations in guidelines can also bias the conversation. It's important to note that pollsters and social science survey designers have been wrestling with problems like this for a long, long time, because everybody knows that the way that you word questions influences the answer that you get, and everybody knows that the order in which you ask questions influences the answer that you get, sometimes by really amazingly great factors. Okay, so I am done, and we will now turn things over to the first of the speakers, which is Brian and Saturnino. As in the previous session, try to limit your presentation to a summary in 8 minutes or so, and then we'll open the floor for questions.
Yeah, I think Saturnino begins.
Okay.
If he can.
Yeah. Can you hear me?
Yeah.
Yeah, just
right. So, yeah, I don't know how much people have heard of this before. Many people joined from the previous session, but I just outline the address challenges on Alzheimer's dementia recognition through spontaneous speech, which, as Mark pointed out, draws on data from Dementia Bank and Talk Bank more recently to address a very present and concrete problem of Alzheimer's dementia diagnosis, and to a lesser extent, disease progression over time. We organized 2 tasks. One of the main goals of these tasks was to avoid the lack of replicability in the studies that existed in dementia recognition through speech. There's a number of these efforts, but in general, there are very few of the data sets are shared. Some of the studies use the Talk Bank and Dementia Bank. Very few studies are shared, and there are problems with the data, even as described on the papers that are used. For example, age and gender biases are not normally taken into account, or taken into account, but not addressed in a way that would control for the fact that these are 2 major risk factors in Alzheimer's. So this was one of the goals, and the other goal was to provide a benchmark data set that people could compare their systems against. So even if they have their private data that they can train their systems on, they could make use of this resource, which has been used by other researchers to have some idea of how their systems compare. So the first challenge, we just did a simple matching of speakers in terms of gender and age to eliminate the bias for Alzheimer's prediction. And we also had a subtask that was prediction of cognitive test scores. So this was an interesting task. We got more than 30 submissions for systems. Eventually, I think 11 or 12 were accepted for Interspeech 2020, many of which, the majority of which beat the baseline that we set, fairly simple baseline, achieving accuracies of over 90% in some cases for prediction, and RMSE scores of as low as, I think, 3.9 for MIMC score prediction, which is not too bad. For the 2020 challenge, we updated the data set. We added some more data. We changed the way the matching was done using propensity scores. So we were able to use more data. We also added some data from the fluency tasks, which were recorded as well with some interviewer data. And we gave less information. So the first tasks, there was detailed transcriptions of the descriptions, and in this task, the current task 2021, there is no transcription provided. So if people want to use linguistic features, for example, they would have to obtain them through speech recognition. So this was also quite popular. We got, again, around 30, 35 submissions. The results will be presented at Interspeech 2021. And again, we got some pretty good submissions, pretty systems that beat the baselines by quite a bit. There's a number of challenges that remain that were not addressed in the first address challenge. We tried to begin to address some of these challenges in the second one. One is the issue of pre-processing of the data. So to perform the task, in some cases, to use linguistic features, people relied on transcriptions. And of course, transcriptions will presuppose a number of steps, diarization, so you get the speech from the patient and not from the interviewer, transcription itself, ASR, extraction of features, of different features, maybe annotation of the transcripts with disfluencies and other things, which is none of which are trivial tasks, some of which are open research problems. The other challenge is the scarcity of data. Not many labs have collected data, but not many labs make these data available. So that's one of the problems. This is obviously due to the fact that these are patient data, and in many countries there are severe restrictions on sharing these data. So it's difficult to or even if you get access to it, it's difficult to share more broadly with the community. The second issue is when I mean scarcity of data, that's particularly true of spontaneous speech. So you sometimes get a lot of cognitive test data, so you can get quite a lot of that, but that's not spontaneous speech. And then finally the issue of how applicable these systems are to actual clinical practice. So better contact with researchers and clinicians to see which one of these tasks actually represent useful tools for people doing research or practice in treating or assessing the progression of the disease of Alzheimer's patients. I think if Brian could talk about the talk bank now.
You have to unmute Brian.
Sorry, yeah, am I unmuted now? Okay, start again. Okay. Can you see that okay? Am I unmuted?
Yes, that's fine.
Okay, thank you.
Yeah,
Okay,
you're
Brian,
on.
Winnie. Yeah, okay. So I wanted to talk about more generally about benchmarking for spoken language, which from my point of view is from the TalkBank system. Of course, there's a lot of other spoken language corpora out there. I'll just say a little bit about TalkBank. It's the largest open access, that is, you can just come on really with no password or with a password that we grant very quickly. For spoken language, it includes 14 different fields, ranging from child language to dementia, aphasia, stuttering, second language acquisition, classroom, and so on. And these transcripts are linked to either audio or video. You can play back over the web, download, and so on. Fairly crucially, it uses a single transcription format for all of these different types of data called chat. So that facilitates the possibility of using a core set of programs for analyzing the data. And actually, we now have a new facility called TalkBank DB where you can download really actually all the data for further analysis in R and Python and so on. Somewhat offline from the current discussion, there's a big emphasis on these fair trust principles in open access databases, open science, and we're really trying to go along with those to make data maximally available, replicable, and so on. Also in accord with the core trust seal standards. So, I don't know how many of you are familiar with all this stuff. Okay, so we have had several benchmarking challenges, benchmarking type challenges. The first one is the one that Saturnino just described for dementia. And we, across the 2 years of 2020 and 2021, the challenge varied a little bit. At first, it was based on a lot of hand-done work of, diarization and segmentation to make the data, consistently available for all the different challenge attempts, but also to have a lot of information there. And then this year, we've gone to a more automatic coding of the data using ASR and basically emphasizing some of the acoustics. So there have been just a lot of papers written on this the particular corpus called the PIT corpus. And as we, I'm sorry, I go back here. The audio for this corpus is really not the best. Actually, these were done on, those little cassettes back in the 80s. But this is really the biggest corpus that we have comparing controls and dementia. People with mild cognitive impairment. So this is really the one really public database that people can use for benchmarking. Another benchmarking effort was the Die Hard Challenge from Neville Ryan has a paper in this symposium about this. This was focusing on the 16-hour-a-day recordings that are taken with the Lena system in the home with little children and their families. And the Lena system does a diarization of who's speaking when and when do they begin and end, but actually that diarization is pretty inaccurate. And so actually there's been an improvement using the Die Hard methods, but to get further, we really need more labeled data. And in order to get this more labeled data, what we're trying to do is make all of these recordings available directly on the web so that people can diarize and tag speakers, having professors can assign their students some of this as sort of citizen science, you might say, or crowdsourcing. Then another sort of effort that really should be engaged with benchmarking is the work on segmentation, automatic segmentation based on infant-directed speech. There have been about 10 different models that have been proposed in this area on how children or programs could learn word forms to pick out words from the speech stream. And none of that, we unfortunately have not set up a benchmark standard for this work. So that's really something that we really should be doing. Okay, one of the points I wanted to make in regards to this, great presentation about TREC and all the details there, and really some of the other challenges that face people who are working with these data that are coming from the web. These are written language data, and there's a huge amount of written language data available from the web, whereas spoken language data is much harder to obtain for various reasons. Well, first of all, everything has to be transcribed, although hopefully that might change to some degree in the future. And of course, even before transcription, you have to, go out in the field and record. And then you have to generate metadata. And all of that is just a huge amount of work. On top of which, there are all these data sharing issues, IRBs that will or will not allow you to share the data, or even some of them even asking you to destroy the data after your project. So there's a lot of that you have to navigate through. And even once you get to that, there's actually people are not really that open about data sharing, and we really need to sort of encourage a culture of data sharing for spoken language. In some areas, it's very good. Child language, aphasia, and so on have been really excellent, but other areas are less open to data sharing. So in a way, our problem here is getting off the ground with enough data. And I should mention that the profit motive is important here, because for Alzheimer's detection, there really is now a huge profit motive because of the prevalence and the increasing prevalence of Alzheimer's. Yeah, I think that's obvious. So some areas that we could really benefit from benchmarking in TalkBank. One that I've always felt was really fundamental was being able to learn language based on the input. Maybe Chomsky put that out, right? The primary linguistic data, the child should be able to take that data and acquire a language. So there have been some algorithms that attempt to do this, but really no benchmarking yet. And then automatic speech recognition for some of these populations that are not currently covered. And Elena's talk certainly went into this about how we could even have, we are going to be adding the Chorale database, for example, for Black English or African-American English to TalkBank. So that would be a great sort of source of training for that dialect. To make classifiers that would distinguish different types of language disorders. In aphasia, there are 6, 7 different types of aphasia. How can they be best categorized? But the problems here are with the gold standard that clinicians themselves don't really agree always on clinical assignment. So that's an interesting problem. We also would like to have different assessment of different language therapies across time. So really, in a way, that might be not just benchmarking, but also competition between the therapies. Then finally, the idea of making a predictor of developmental status based on, we have a lot of longitudinal data for child language development. And you can use handcrafted tests that are developed by speech language pathologists, but you can also use machine learning approaches. And it turns out the machine learning approaches are actually doing better than the handcrafted SLP tests. So these are all areas where we could do more benchmarking. I think I also had some references here, but okay, I'll stop sharing.
Okay, the floor is open for questions. We have 3 minutes until the end of 1/4 of our remaining time. So that's probably enough time for one question. I'll ask a question if nobody else jumps in. It's partly a statement and then a question. The statement is that Brian mentioned that there are some areas like child language where the culture of sharing is strong. And I need to point out to everyone that that's because of Brian.
I'm supposed to defer also to Roger Brown, who
Okay.
was really an initiator, but we're all, I think it's really true to some degree, but it's also true that people in child language just, really, yeah, they're good.
I think a point to make is that this is not just a matter of policy, ethics, IRB, laws,
Right.
but culture.
Yeah, you have to push people. You really have to push people.
Back in the medical area, although people like to very often say, well, because of HIPAA, we can't let you see our data. That's actually false, as many examples, including the PIT corpus, show. If you approach things in the right way, then the IRB and the patients and so on are not going to.
Yeah, totally agree.
I could just comment.
I think everyone who isn't talking should mute themselves. Saturnino, maybe?
Yeah. I just wanted to make a comment about sharing in the medical area as well. So Brian mentioned the profit motive. Sometimes the profit motive works against sharing, of course. We have access, for example, in projects to data, speech data collected by pharmaceutical companies, for example, which they won't even let us. I mean, we have access to it by training our models and then giving them their these models so they can test it on their data, but they won't even let us see the data. So there is potentially quite a lot of speech and language data out there, but in the hands of pharmaceutical companies that won't share them, and that's not just a question of ethics and other things. But
and of course, now that Amazon and others, Apple, are interested in getting into the wellness area, there's another dynamic. Their attitude toward things is different from the pharmaceutical companies and from each other. So we'll see what happens there.
Yeah.
Well, the other thing is recording in the home with the voice-assisted systems like Alexa and Siri. So there's a lot happening, and I think this may change a lot in the next few years.
Okay, so we are now 1/4 of the way through our hour and a half, and so it's time to go on to the next presentation.
All right, that's me, right?
Yeah.
All right. So, all right. Thanks for having me at this workshop. So I'll try to keep it short. I'm on the West Coast actually, so I had to wake up at 5:30 for this session. I should have checked the schedule earlier. So I'll try to keep it short. I put this here actually, mostly for Mark actually, just so you know how to pronounce my name. I know that's an issue with lots of people, so it's Douwe Kiela, so you can just.
I was going to ask.
Yeah, I figured that. You dodged it a few times, very, very aptly, I should say. So, but it's just Dow as in Dow Jones. All right, so as I said, I'll keep it short. So I'm here to talk about Dynabench. Dynabench is a research platform. It's a website essentially where we try to rethink benchmarking. So benchmarking has been very successful, but we think we can maybe do even better and embrace modern technology even more. So we're trying to use this platform for challenging existing notions to see if we can make better progress. So that means moving beyond a lot of the things that are currently kept static, like the data sets or the leaderboards or the metrics, and making all of that stuff dynamic. And we think a crucial component of that is to have humans and models in the data collection loop together. So I'll give you an example of what that means in a bit. And the other thing is, can we evaluate models along multiple axes? So rather than just focus on accuracy, can we focus on things like fairness and robustness and throughput, memory usage? So how green is your model, that sort of stuff. So here's a long list of things that we're trying to solve that Mark already highlighted. So I won't go over all of them one by one. But we think what we have in the platform is a solution to many of the issues that are currently prevalent in the benchmarking paradigm. And we hope to work with the community to try to overcome a lot of these issues if we can. And we think part of the solution is to make things dynamic and to admit, I don't know if people saw Chris Potts's keynote from yesterday or the day before, where he also talked about this. We have to admit that benchmarks are imperfect and it's impossible to make a perfect benchmark. So we should acknowledge this and build a platform that can account for this if things go wrong. So we should be much more dynamic sort of from the beginning, and as new things emerge, so as we find biases in data sets or as things go wrong, we can try to course correct automatically without losing a lot of time as a community. So we think part of the solution for that is to have multiple tasks. These tasks, they collect data over multiple rounds. and to really turn this into a community effort where the tasks are owned not by us, Dynabench or Facebook. They're owned by task owners, and these are people from academia, and they have essentially full freedom to do whatever they want with their own tasks. So the platform just enables all of this very exciting research. So what it enables specifically is dynamic data collection with models in the loop. So you can try to fool models to try to find examples that the current state of the art cannot yet do. So this would counter saturation and things like that. And we would have dynamic leaderboards that rely on evaluation as a service. So rather than having people self-report their accuracy and say, I got 90%, they actually have to upload their model, and then we test their model and we verify that they got the 90% accuracy that they claimed. So far, we've created some very successful data sets that I think we'll see a lot of uptake in the community. Published a whole bunch of different papers about this. Enabled some massive challenges. So the Flores 101 large-scale multilingual machine translation challenge at WMT is fully hosted on this platform. We've collected over 400K, probably even more than 500K raw examples on the platform already, and we're hoping to keep growing this way. So I thought I would give you a very quick demo because it all sounds very abstract, but it's all very simple. So this is dynabench.org. We currently have 4 main official tasks. So if we look at something like sentiment analysis, what you see here is, let me just get rid of this a little bit. Yeah. So what you see here is a dynamic leaderboard, which means that I can specify how much I care, for example, about fairness. And as you can see, this changes the ranking on the leaderboard. I can specify how much I care about certain test sets. So maybe I only care about the SST, the Stanford Sentiment Tree Bank, and I don't care about other things. So I can do things like this. I can check out the specific model, how well it does on all these other test sets that are not a part of the leaderboard, but that we still score them on using this evaluation as a service framework. What you can do is you can create examples. So we can try to do this for an example together. So let's say we're looking to write a positive restaurant review that fools the model into predicting negative. So we could do something like, the new manager really turned it around, but this place was the worst. Terrible service, horrible food, bad everything. So if we give this to the model, we can check what the model predicts, and yay, we fooled the model. So as we can see, with 66% probability, or 66 probability, I guess, if this is a binary classifier, the model predicted negative, but a person would say that this is a positive review, right? So that's the basic idea, and these examples are all collected, and then models are scored accordingly. So I think this is interesting because it enables all kinds of interesting research questions about how do we deal with distributional shift? Should we care about IID or non-IID? Like out-of-domain generalization is a big topic in machine learning these days, and it's only going to keep getting bigger. Can we come up with better metrics? So the ones we have now are pretty rudimentary, but we can probably do a lot better than what we have right now. So just a final remarks. This is a community effort, so please join our community. We're looking for people who can fool models, who want to contribute new models, add new features or metrics. This is an open source code base, and we're also very interested in talking to people who want to start new tasks. So if there are things like Alzheimer's speech recognition related tasks, we would love to support that. So that's all I had. Hopefully that was short enough.
Perfect. There's 14 minutes or so for questions, so the floor is open.
Can you call on us?
Brian, consider yourself.
Okay. Yeah, I really agree with the importance of putting the human back in the loop, of course, as a psychologist, right? But I mostly saw the human there making judgments of relative values of dimensions on the Dynabench. And that seems like one important dimension, but the other seems to be the human making that judgment that oh, well, it was this used to be, the manager turned this around, you know, so it's the fact that all the bag of words is pushing you to the negative, but the actual higher level understanding of the communication is pushing you to the positive. And you see so much of that in these sort of adversarial questions. And to what degree can you really, that's putting the human into the loop in a very different way, right? And Dynabench isn't really doing that, or is it? I guess is really my main question.
It isn't doing what exactly? You mean
well,
adversarial?
I mean, the human is in the loop by moving those sliders.
No. So those are two separate things, right? So the human.
Yeah, that's what I'm saying.
So
they're two separate things.
Yeah. So right. So maybe I should have been clearer there. Sorry.
Yeah.
So there are two different components, right? One is we have a dynamic leaderboard where you can specify your own utility function. So if you want to pick a model, like if you work at a company like Facebook and you have to choose which model to deploy in the wild, you care about multiple things in different ways, maybe than the academic community, right? So in academia, we care mostly about task performance. We don't care so much about like inference time or fairness or robustness or things like that. Luckily, that's changing now. But you know, it's very focused on accuracy. And so what we're doing with this dynamic leaderboard is we're allowing people to specify for themselves.
You know, I got that part. That was obvious.
So that's completely separate from the human in the loop in data collection, where the humans are trying to fool the model, and we can look at things like the model error rate. So how easy is it to fool the model? If it's easy to fool the model, that means that you probably don't want to deploy it in the wild because it's not very good, right? So even though it might look like it's very good on the test sets that are static, if you actually subject it to human scrutiny, if you will, then
no, I got that, but you don't have anything in Dynabench that actually takes that input regarding why that was a model was wrong and uses it dynamically to somehow change the model, right? I mean, that's work for the future, isn't it? It's not part of Dynabench.
So yeah, partially, right? I mean, so what we do with the data that we collect is we turn that into a new round, and people can train new models on that round. So all of the data that comes out of the platform is completely open source, right? So we encourage the community to train on this new data and try to fix those issues, right? Okay, and I think what you said actually about bag of words is very astute, because so we also have a paper from a couple of months ago where we showed that if you just shuffle word order in your pre-training corpus and you train a big model on it, everything still works. So that these models are like fancy bag of words models, even the state-of-the-art NLP models, rather than like sophisticated linguistic reasoning machines.
Okay, thank you.
So a couple of other hands, several other hands were up. Anders, you're the one that I see at the top of the list at the moment.
I think Victor was first.
Actually, Victor was before you.
Fair enough. Hey, can you hear me?
Yeah.
Yeah, cool. Thanks for a good talk. I really like this line of research, actually. But one thing I was wondering about is that, like, one of the reasons that like high quality benchmarks are like far between is basically that they're very expensive and like time consuming to collect. And I'm wondering about like the motivation to contribute to Dynabench, because like usually you pay crowdsourcers to yeah, I don't know, on Mechanical Turk to do your task, and you give them like some monetary compensation for that. But here it seems that it's more gamified, if I understand it correctly. So it's maybe less examples, but more tricky ones.
There are two ways to talk to the platform. One is the web front end that I just showed you. The other is the Mechanical Turk front end that you can use to do large scale data collection. So Mechanical Turk workers, they would see exactly what we just saw, but then specifically tailored for MTurk with clear instructions and things like that. So it is possible to just pay for your data, and that's what we've been doing. And so you're right that they're expensive, but you know, it's not that expensive, I think, in the scale of things. I think Sam Bowman had a nice slide in his talk where he said that, you know, GPT-3 training was like 5 to 10 million. So a data set of like a couple 100K is not even that expensive, right? Relatively. So the other thing about why you would contribute as a normal person on the web interface, I mean, we're trying to engage the community to see if people find this interesting, right? So gamification is definitely a thing, and you can even earn badges and stuff like that. So what we're really hoping is that linguists, for example, become very interested in trying to find out where current state-of-the-art models still fail, right? Because so linguists are awesome at finding these weaknesses. So if we can get them to engage with the platform, I think that would be very successful. Cool. And so maybe, you know, if they're like ranked number 1 on the model breaking leaderboard, this is something you can put on your resume, right? Because that's quite a skill to have, I think. So.
Okay, Anders, you're up.
Cool. Thanks for a great talk, Douwe. I'm a big fan of Dynabench, but it seems like there's an assumption. So you talk at least in the YouTube video, you talk about like how we should abandon the assumption that we can sample language IID, but it seems that there's an assumption in your system that the humans are IID. And is that something you worry about, or is it, or are you basically assuming that because you sort of have this adversarial search strategy to find the weak spots of models, that's not a problem?
Yeah, so I think that's an open research question, right? Like what happens with adversarial search and the distributional shift that occurs with it. But my main point, I think there was just that if you really want to claim to have natural language understanding, you should have strong generalization, which means that you should be able to generalize beyond IID, right? So that's why I keep hammering on like the worst case is what matters, because that's also what humans would expect if they expect you to be able to speak language, right? So if I use words that you've never heard, you can probably still understand it just because you speak language, and not because these words were or were not in your distribution during training.
But this is the worst case as per the imagination of linguists or members of the NLP community.
Anyone, yeah.
You know, would probably
not. Turkers, or like, so there are different ways to steer them in different directions too, right? So if you want to have diversity in the sentiment data set that we collected, we showed that you can prompt users in different ways and they will get very different, they will find very different examples, right? So you can make sure that you have very good coverage over a very wide range of phenomena that you want to capture in your data set.
Cool, thanks.
I think Valia Cardoni had a question before, had a hand up before.
Do you hear me, Mark?
Yes, I do.
Yes.
Yeah, no, sorry, thank you. So it was just covered from the first question, actually, that was asked to the speaker. I won't pronounce the name. I'm very bad. I'm Greek. Sorry.
No problem.
So thank you.
Okay, other questions? I have one which has to do with the time scale that the benchmarks are meant to operate on. And I think the situation is very different if you're trying, for example, to decide whose system to buy, or you're trying to decide whether a system that you've developed is good enough for a particular task. There are all kinds of constraints, all kinds of ways to go wrong in answering those questions, as well as ways to go right. But if the aim is to figure out how to solve a problem where to start with you just have no clue, or at least there's no agreement about how to proceed, and it's not even clear that it can be done, but you're kind of hopeful that over a span of 10 or 20 years, maybe you can make some progress, that puts a different set of constraints on the benchmark design. And I wonder if Dynabench has any aspects of that, or is it because you're required by your company to have a somewhat shorter term outlook.
Yeah, so I mean, I should stress again that the company has very little to do with this. This is basically just me trying to do cool stuff with the community and with my friends. So yeah, to answer your question about the timeline, I think one of the nice things about this platform is that it's flexible on timelines, right? So we're not forcing anyone to start a new round. So the first round could be 20 years. You know, there's nothing stopping anyone from doing that. And in fact, actually, when we introduced this, glue was just saturated and super glue was saturating. So we expected lots of new models to come out very rapidly that we could then put in the loop in these new rounds of data collection. But what happened is that we've stalled a little bit. So we haven't needed to collect as many rounds as I would have thought. So that's a good thing, I think, for like the longer term. So we can stop here and like collect lots of new data for the next leap, right?
That's an answer to a somewhat different question from the one that I meant to ask. I didn't really mean how long the benchmark competition lasts, but rather how long the research project, the research trajectory lasts. And at least the lesson from the efforts that started in the mid-1980s in this area and then in the early 90s in the text area are that you need to hold new competitions every few months, or at least once a year, let's say. And you need to change the design, either change the data or change the scoring or something, precisely because you get saturation.
Right. Yeah. So that's what this framework is all about, right? Like so you can have as many or as little rounds as you want, right? And so I think when glue was introduced, we thought that this would last for a really long time. I don't know how others felt, but when glue came out, I was like, whoa, this is really hard. And it took, as you can see here, about a year for it to saturate. Super glue was less than a year, right? So we are making a lot faster progress now than what we were making in the past with things like MNIST and Switchboard and things like that, right? So maybe now is the right time to introduce a platform like this, right? And at the time, progress was a lot slower, maybe.
Okay, so we are actually at the time, well, we're 2 minutes early, but let's go ahead so that we have a little in the bank. Anders is the next speaker.
Sure, thanks. I'll do a brief summary of my talk without slides, I think. So what I'll talk about here aligns really well with Chris Pott's talk, but also what Douwe just said. It's sort of less cool, less radical, sort of a Scotch tape version of Douwe's talk, I think. But it aligns in the sense that it's all motivated by this observation that I think has become a consensus, at least in this choir, that language is really a moving target and not something that we can sample from and say, here's something that's representative of language at large. So what I'm doing in the talk is just sort of listing 5 very simple things that you can do to fix or make existing benchmarks more interesting for researchers, to account for some of the dimensions that we've talked about in the first session and also in this session, or at least 4 of them are sort of easy sort of add-ons. And that's why I say this is less sophisticated than Dynabench. So the 4 first thing that I talk about in the talk are the value of adding timestamps to your data. This is a very simple thing, of course, but there's just a lot of benchmarks out there with no information on when the texts were written, when the examples were constructed. And if we want to account for temporal drift, which is one of the challenges that we're facing right now, this is just very useful information. And in fact, take something like PenTreeBank, that data is actually out there. It was just not distributed at large, not made widely available, but you can dig out that information. And I think only now we're realizing the value of having that information. The second thing on my list is the demographics of the writers or speakers, the people producing the sort of linguistic input here. It's an open question, and I think this is a really interesting question, what kind of demographics we should be interested in. So obviously we tend to look at gender and age, maybe race, because they're protected attributes and something we need to worry about. But there's other variables, of course, that we could look at. So Brian's talked about aphasia, dyslexia is an obvious sort of variable, level of education, perhaps, whether you're bilingual or not, a first language, et cetera. And that information, I think, is really important if we want to look at how robust our systems are across groups of people. And again, oftentimes this data is available. It's not always clear whether you can distribute it, but if you can, there's a lot of value in making this part of your evaluation data sets. The sort of obvious next thing on the list is the demographics of the annotators if you have annotations in your data. Because again, as Valerio was talking about earlier today, people have different opinions about the kind of target variables that we want to predict. And it's important for us not to kind of bias our systems toward a certain demographic, of course. Later, Victor will talk about guidelines and the bias introduced by guidelines. There's interesting interactions between demographics and guidelines. So people read guidelines in different ways depending on their demographics. And so all of this is sort of interrelated in so many ways. The fourth thing on the list is just having multiple annotations. And again, this is one of those things that back when we did some early work on dealing with disagreements and multiply labeled data, we were reaching out to a lot of people that had done resources like tree banks, and actually often they would have multiply annotated examples that were just kind of discarded after adjudication. So the data was there, but they didn't really think about distributing it. And I think there's a lot of value in that data if we want to look at the systematic disagreements and figuring out where kind of systems could actually potentially be right in several ways. And again, there's interesting interactions there with demographics because it might be that people disagree for demographic reasons, or that there's more or less disagreement within certain groups compared to others. So the fifth point on my list is just that one way of improving your data is making more data, or one way of improving your benchmark is introducing another one. And what I mean here is that, if you want to understand a loss landscape, you need more than one reference point. And I think there's an interesting analogy here to surveying where like a single benchmark, so like a single mark for positioning a leveling rod is not very informative of the landscape as such. We probably need more like, a dozen or more different samples to really understand the complexity of the landscape. So, of course, Dynabench, you can think of as sort of a search strategy, a very clever search strategy within this landscape. And as Douwe just talked about, it's sort of an empirical question, what the pros and cons of that search strategy would be, because obviously adversarial search is also biased in many ways compared to just randomly sampling across the landscape. But I think these are sort of important points that are kind of aligned with this more and more consensus view that language is a moving target, and that we're all sort of different in our expectations of what the outputs of good NLP systems should be. But hopefully these are the kind of things that can sort of bridge the gap between what benchmarks actually look like and what we all sort of philosophically feel benchmarks should do for us. yeah, I'm happy to take any questions.
Douwe. Oh, no, you're clapping.
I was
Ellen,
clapping, yeah.
Ellen, you raised your hand.
Yes, thank you, I did. So I want to go to this. I mean, I completely agree with the idea that you need more than one benchmark. And while dozens is probably expensive, at least several. But I also want to explore this idea that Dynabench provides that. My worry with Dynabench is more that there is a set of models in there, and so you've already chosen what it is that's going to be tested. And how does that protect against missing out on a whole weird approach, which is actually quite good, because it's never there to begin with. And I guess that's not really, that was probably more a question for Douwe than you, sorry. But what you said made me think of that.
Yeah, it's a very good point. I think there are two things, right? So if such a model is discovered as like the weird one that is very different from existing ones, then it should do much better on our current test sets, right? So people can just submit this model to the system. It will be scored on all the previously collected data. So we really have dozens of different data sets inside a benchmark on Dynabench. And if it does well on all of them, then there will be a paradigm shift, and we will put this new weird model in the loop and collect more data against this model, right? So that's sort of built in to the system that this could happen and that we can correct for it. But I think your underlying point is the same one Anders made about adversarial data collection being biased against the models that are in the loop, and that's very true. I think so. One way around that, or to make it less bad, maybe, is to have ensembles in the loop, right? So rather than just having one specific BERT model in the loop, you could have a very wide range of different models. So including Word2Vec or like old school SVM or things like that, to make sure you have a very good coverage over all the models that have been discovered so far.
As sort of a follow-up question to that, are you worried about fairness or decreasing, adding more data in the loop? If you sort of assume that certain demographics have error examples that are harder to come up with, sort of like just further away in imagination than other groups, and this would sort of bias systems to solve the problems of certain demographics rather than others?
Yeah, yeah, that's something we're thinking about a lot. So we have this fairness metric that we introduced, right? And so currently it's way too rudimentary. So what we're doing is we're looking at proper names. For example, if we find James, and then we're replacing that with an ethnically different name like Jamal, and then we're seeing if that affects the prediction at all. And so if it does, that's a bad thing, right? So this is the sort of stuff you can measure where like you need to have demographic parity. And you can do the same with gender and maybe other things. So we are trying to think about this, but if you do this with just perturbations that are based on heuristics, that's problematic, right? So we're thinking about how you can do this in a model-based way so that you can get better demographic coverage, even if you don't have the raw data that has the right demographic properties, because ideally that's what you would have, right?
Cool. Just before letting you ask your question, Brian, I just wanted to follow up on Ellen's question and say, so one reason for talking about a dozen benchmarks here is because I'm still sort of struggling to think about how we should do statistical. So like, if we don't buy into the idea of having representative samples, how do we do statistical significance? And doing significance over samples that were sort of independently collected doesn't sound to me like a perfect idea, but definitely sounds better. And for that, we need, a bunch of samples to kind of compute significance over those. And that at least to me sounds a little better than doing it over data points.
If I can riff off of that. So there's a nice paper from Anna Rogers on QA dataset explosion and taxonomy of NLP resources for QA. And so they say that 80 new datasets have occurred in this domain over the past 2 years. So we have way more than dozens, which I think is a good development.
Except that those aren't comparable to one another. Right? I mean, so you can't really, you don't have 80 data sets for the same task because those are wildly different tasks from one another.
So that's what they try to do in that paper, right? To design a taxonomy that sort of categorizes them along those lines. Yeah.
So Brian, your hand is up.
Yeah, I hope you indulge me with a really, it was really following up on Mark's question about timeline. You know, so it strikes me that there are these problems. Well, I mean, certainly the sentiment detection has a lot of them, but I keep thinking about this platform, the train station platform that was either, you know, a roof or a station or a platform. And, you know, there are really good, solid reasons why people are coming up with these different labelings of this picture. And I don't have a good sense of how this benchmarking effort is encoding the knowledge representations that underlie the alternative you know, judgments that are made in a perfectly reasonable way by people. In other words, these are disagreements that have good reasons for being disagreement. And so in a way, somehow there has to be a way of saying, you know, what if it's Jamal versus James, there's a reason that you are attributing a different sentiment when you know it's Jamal, you know, stereotyping or whatever. So underneath there has to be much more knowledge representation, it seems to me. And I just don't know how that is going into this program. Maybe it is. I think, you know, Anders probably has a little bit of comment on this too. Yeah.
Right, and I think in some metrics you do see that, like Rouge, for example, would link up to WordNet and talk about concepts rather than just word forms, for example, and that's a little bit of that. But I think some of the disagreements are also sort of beyond what you would be able to resolve with the knowledge base. So, for example, in argument mining, whether something is an argument or not, maybe something that certain demographics have different opinions about. And I don't think a knowledge base is going to help here. So I think it sort of depends on the task.
But the demographics is part of the knowledge base. That is, you know about the person where they're coming from. So the more data you can pull in to justify the differences that people are making, these are actually some of the most interesting things.
Sure, but in the Jamal case, you don't want your classifier to pick up on that, right? Because you don't want it to be racist, basically, right? So some of the information that you might have is not relevant to the label that you're trying to produce.
Okay, I guess I was just asking the scientific question.
Right, but I think I mean, so what you're saying is really a great point, right? And I think there's some very interesting work by Eli Pavlik and Tom Kwiatkowski, where they do this analysis on natural language inference, and they find that there's a lot of disagreement, and like you can really like cluster people like by whether they say that something is a contradiction or neutral or things like that. And so in NLI, there's a couple of papers also that argue that we should be doing density estimation. So rather than saying like this is entailing or not, we should say like, okay, the probability that this is entailing is this much. And like have a proper density estimate where you need to have lots of annotations in order to get a proper density estimate.
Yeah, and I think it goes back to what Mark was saying about survey research too. And there's just so much in that area, yeah. But how does it get into the code of Dynabench? It's what I'm trying to see.
So all of the examples we collect are validated, right? So if we can get hundreds of people to validate the same example, then we would release all hundreds of annotations. So that would allow people to.
Right, but you don't know why. You don't know why there are these differences, do you? You know, unless you're getting deeper.
Well, I don't want to talk too much about Dynabench because Anders also I think what he's talking about is also interesting. But so we're also collecting explanations. So if you're logged in on the system and you generate one of these examples, it will ask you, why do you think this fooled the model, and why do you think this is the right label?
Okay.
So we actually do collect rationales for this sort of stuff.
Oh, okay, okay.
Ken has a question, but before he does, I just wanted to make a distinction that has come up a few times and will come up again. And that is, so everybody agrees that there are many, for most tasks in the speech and language area, it's not the case that there's a single right answer. There are certainly, the clearest case is translation, where there are multiple. That doesn't mean that every answer is right. Not every translation is adequate or correct or even in the right ballpark, but there isn't a single correct translation. But there are two different ways to think about that. One is that the evaluation or answer in a particular case is a distribution over answers. That's a sort of statistical approach. But then the other approach is the logical one that says that, well, actually it's more complicated than that. There are various different ways to think about it, different patterns, different ontologies, different conceptual organizations, different things you might be thinking about. And those, the distribution over answers is actually generated. It's not primitive, it's generated to a large extent by those other factors. Okay, Ken, it's all you.
Yeah, so, you know, I mean, I agree with what Mark said there totally, but let me choose a rather trivial example where it seems like, you know, intuitively there should be just one answer. And this is part of speech tagging. And part of speech tagging got stuck sort of almost at the beginning because I think not because the technology was so good and couldn't get improved, but because the measurement couldn't actually measure improvements. So the standard measurement is that there's a gold standard with one and only one right answer. And if you look at the inter-annotator agreement rates, it's about, you know, there's about a 3% disagreement rate. Then if you look at what the system performance is, it's getting about 3% differences with the gold standard. There's a difference though, that is if you look at when two people disagree, it's a difference of opinion. When the machine disagrees, it's wrong. Now, I don't really know how to distinguish an error from a difference of an opinion, but I know it when I see it. It's like, you know, the Supreme Court justice said about porn. Now, I think there are ways to measure this. So I think what they do in Trek and web search and in Bleu and so on is actually a reasonable way. That is, if you have more than one reference, then you could actually measure the differences between a difference of opinion is when the machine agrees with any of the judges, and an error is when it comes up with something just completely nuts that only a machine could do. Now, I think when I mentioned this stuff to the people, like to Mitch Marcus, who was involved in tagging, he was saying he just couldn't get money from the government to label anymore. And so that's that. And I'm sure Ellen will tell us about funding woes and so on. And she probably knows more than we want to know. But anyway, what we do in web search, where money really isn't a problem, is that you do post hoc judgment. You have all the machines come up with all the candidates they do. And then after they come up with the candidates, you send it out to the judges. But I guess maybe what we're saying is what you would do in an ideal world where you can afford to do it. But what I am kind of worried about is that whole fields dry up, like part of speech tagging, because you can't show any progress, not because you can't have progress, but because the measurements won't show it, won't find it. Anyway, enough said, and it looks like I got John to speak up.
Yeah, John, you're on.
I was going to wait to make that point during my talk, but thank you for raising it now about inter-annotator agreement. We've had many of our government sponsors say, you know, why is your performance on language X so different from language Y? And as if there's something special about those languages. And there might be sometimes, but in general, it turned out to be largely an issue of inter-annotator agreement. That for some languages where the guidelines are not quite as strict as for others, annotators feel free to do whatever they want. And so my plea is for any time you collect any new corpus of any sort, measure the inter-annotator agreement, or I should say disagreement, because that puts a gate on your performance, basically. And what's important to know is that you don't need to do it for a lot of data, because you're not trying to get an exact estimate of that. All you're trying to do is get a ballpark figure. So just a couple of thousand. I mean, something small. Don't go overboard, and always measure it and always report it, because then when you're measuring performance, you're always measuring performance against that inter-annotator agreement. We did an experiment in the Babel project. This was Mary Harper was the program manager at IARPA, and we had 26 languages there. Okay, and the question was always, oh, why is this? The error rate here is, my God, is like 3-4 times as much as the error rate for this other language. And Mary always had the idea that, oh, maybe the that the error rate for English is much lower than other languages is because we've been working on English all these years. But we insisted that she do an inter-annotator agreement experiment, and she did. We thank her for that. She did it among like 3 or 4 languages, and wouldn't you know, the error rate was on the same line as the inter-annotator disagreement in that case, because the squared error rate against error rate, and it was right there on that line. So I think that just bore out the idea that we're gated by what the annotators do, and I don't think we need to do anything about it except to report it when we report error rate among different conditions, different different languages, or different whatever it is, different domains, different whatever it is. I think if we have that data, and I don't think we've done this often enough. Let me put it that way. It should be part and parcel, and since Mark is right there, LDC, I think it should be part and parcel of every corpus, that there is a part of it that's devoted to inter-annotator agreement and reporting that number, all the time. That's my point. Thank you.
Thanks, John. Well, it's actually exactly time for the next presentation, which is Victor and Anders. So whichever of you is taking the lead, go ahead.
I am. Let me just share my screen. I think I'll do like Douwe and just kind of rush through my presentation. Shouldn't be that long. Yeah, cool. In this short paper we submitted to the workshop, we examined what we call guideline bias in these Wizard of Oz dialogues. So basically, real brief, when you're collecting data set for like a task-oriented dialogue task, which is some kind of task where a user interacts with like an automated agent in order to achieve some sort of goal, such as like booking a restaurant or a movie at a movie theater. You usually use this setup called like the Wizard of Oz method. And it's this setup where crowdsourcers play this role of both the user as well as like this automated system to simulate like this kind of conversation between the two. And both the user and the agent will like follow some sort of pre-specified guidelines, where these user goals and like these clarifying questions need to be asked are defined. And these annotation guidelines are usually intended like to train these annotators, and therefore in some kind of sense also prime them for better or for worse. And kind of what we focus on in this paper is this unintended bias that arise from how guidelines are formulated, which is kind of what we refer to as guideline bias. And we examine occurrences of guideline bias that stem from two different data sets that use this Wizard of Oz setup. And the first one is this Coach conversational preference elicitation dataset, where we examine how a lexical bias in the guidelines can influence the annotators, both the agent as well as the user, and what the downstream effect of the lexical bias is for model generalization. And secondly, we also examined the Taskmaster1 dataset, where we analyze how this order of described goals also influence the conversation. And the first data set we looked at is motivated by this lexical bias. The task is an agent seeks to like extract movie preferences from users by asking them questions in like this conversational setup. And in the guidelines, we see that more than like 50% of the sentences contain different inflections of like, as seen on the right. And we note that in 72% of the instances, the agents use some form of like in the first dialogue turn. And in that case, 52% of the users also respond with some form of like. And our assumption here is that this kind of contributes to this overly optimistic estimate of the model performance, as it kind of hinders generalization towards alternative phrasings of these preference expressions. And we study this priming effect the guidelines have on the users by conducting this small crowdsourced experiments using Mechanical Turk. And we here ask different people what kind of movies they either like, love, or prefer as priming verbs. And we then observe what kind of verbs they use in their response. And what we can note from this is that given a certain priming verb, the users are much more inclined to respond with the same verb to describe their preference. And as we can see from the figures, it's somewhere around like 50 and 60% more likely compared to other verbs that also can be used to give indication of some sort of preference towards something. And we kind of frame this preference elicitation task as like a sentence classification task, where we kind of annotate or like label sentences in the data set if they contain preferences towards either movie genres, or like if they contain no preferences at all. And what we do is basically we examine this downstream effect by replacing all these instances of like in the test set with synonymous words or phrases. So we would basically create 5 different test sets. So we have an original one and 4 perturbed ones, or augmented test sets. And we also collect a small, like out of domain test set, where we, in the wild from Reddit, scrape comments that discuss movie preferences. So we take all these comments and we label them if whether or not they contain different preferences towards like movies or genres according to the same instructions the original authors also annotated their dataset by. And what we generally see is that this occurrence of like is also much less frequent than we find in the CCPEM dataset. And we train two different models on our data, an LSTM and BERT model, and we measure the performance in F1. And we evaluate the models on this unchanged test set, or like the original one, and the augmented ones, as well as our Reddit test set. And overall, we can see that BERT performs much better on our benchmarks, both for both models, we observe a drop in performance when examples are perturbed and the word like is replaced with like these synonymous words or phrases. And especially when like is replaced with kind of these longer phrases, the models see a bigger drop in performance. And we see that the BioLSTM is especially sensitive toward this. And we also see that both models, or in both models, we also see like a significant loss in performance when we evaluate on our outer domain data set, up to 30% for the LSTM and 13% for BERT. And we kind of try to combat this lexical bias in the guidelines by proposing a like simple data augmentation method in order to attempt to create a less biased resource, basically. And the idea is here that we use different paraphrases of the word like, and we replace them in 20% of the instances in the training set. And we then evaluate our model again on these 6 test sets, basically. And we can see that when we train our models on our like debiased resource, both models become more invariant towards these perturbations. And it's also important to note that we generally don't see any loss of performance on our original test set. So this essentially is a win. And we can also observe that we also get improvements on our outer domain data set, which is kind of like, because since the Reddit test set was collected separately, it was kind of expected that we will see a big drop, but we can see that when we also train on our less debiased resource, we also see an improvement on our outer domain test set, which kind of which means that the initial drop in performance is partially explained by this guideline bias and not only this distributional shift. And we kind of stress that this is not like an intended solution to guideline bias, but in this case, like this lexical bias. But in our experiments, we do show that like models trained on this simple debiased data set generalizes better to out of sample data, and showing that this bias towards like was in fact one of the reasons that the baseline classifier performed poorly on the data set. So the second one is where like we examine the order in which the goals of the conversation is described to the annotators in the guidelines, and how they can also bias the structure of the conversation. And we examine this phenomenon in the Taskmaster 1 dataset, and it consists of conversation between users and agents where they seek to accomplish goals by booking movie tickets to theaters. And they specify a series of requirements that these users need to lock in during the conversation, such as like the title and the theater name and the city. And the idea here is that when booking tickets to go to see a movie, we can specify the movie title before the theater or vice versa, but models may not become robust to such kind of variations if only exposed to very biased examples. And we cannot quantify this by computing the probability that a goal is mentioned before another one in the dialogue, given that the guideline does so as well. So for example, if the movie title is mentioned before the theater name in the guidelines, is the same also true for the downstream conversation. And the Taskmaster 1 dataset was collected using 2 different guidelines, which is a smart thing to do in order to reduce this bias. And we can kind of investigate this downstream effect of the bias, or like the difference between the 2 different sets of guidelines. And we here show the heat maps of the relative probabilities, and we can see that the guidelines have a clear influence on the structure of the conversation. For example, in the first guideline, we have the order movie name, city, theater. And we can see if the movie name is mentioned before the city in the guideline, there's a high probability here. In this case, it's 75%, but the same is true in the dialogue. And in the second guideline, the order is switched around, and we can see here that the probability here is now only 57%. So basically, we examine in this paper, we examine guideline bias in 2 Wizard of Oz style dialogue data sets, and we show how this lexical bias for the word like in the guidelines can lead to a bias for this word in the dialogues, and how it influences model performance when there is an absence of this word. And also how it can somewhat be mitigated using these data augmentation strategies that we propose. And we also analyze how the order of the guidelines affect the structure of the conversation. So I'd be happy to take any questions if
John has his hand up. So you're on, John, unless it's still up from before. Maybe John just forgot to take his hand down. So anybody else? Brian.
Oh, I'm sorry, I didn't know you had to take your hand down.
Douwe is before me.
Yeah, thanks.
So John, you take it down the same way you put it up, pretty much.
Okay, I just did it. Thank you.
Got it. Yeah, so I thought this was super interesting. So I was reminded of the recent papers that have been arguing that we need to have data set cards, right? And also kind of going back to what John was saying actually about, and what Ken was saying about inter-annotator agreement, and that we have to be very explicit about the limitations that exist in our data sets, right? So I was wondering if maybe the solution to this sort of issue is to specify how different your instruction distribution is from the regular frequency distribution of English, for example. So is the solution to this to just document it better?
I'm not quite sure about like the perfect solution to this. We kind of mentioned in the paper that like using multiple guidelines is a good idea, and as Anna's also mentioned in his talk, like embracing the vagueness. So maybe like leaving it up more to the annotators themselves, more as opposed to like defining very strict guidelines that users or like annotators adhere to, basically. but yeah, it's a good point. Like, I think there is a real danger of like getting more guideline bias by over documenting stuff. If that makes sense, yeah.
Okay, can I ask my question, or you want to pursue that?
Yeah, no, sure, go ahead.
So this is mostly about the first part of the talk, is more of a reaction that it reminds me so much of this huge literature in psychology or psycholinguistics called syntactic priming, which of course is based on the semantic priming literature from the 70s and 80s, and then the finding by Pim Leveld, and then followed up by Catherine Bach, that people will just echo the words and even the syntactic structures in a question in their answers. And so the fact that like is picked up in this way, just, I sort of thought you should publish your results in psychological science, right, which is, that's just an observation, really. But then I didn't quite understand how, when you went to the debiasing, I kind of missed this part where you threw out a lot of more longer constructions, like had a positive view of, or whatever it was, and that was your method for debiasing, was to not hone in on the word like. Is that what you were saying there, or I just sort of missed that?
Yeah, so I'm kind of rushed over that a bit, but the idea was to go into the training set and remove these instances of like by replacing them with like these synonymous phrases that also have a how do you phrase it, like replacing them with one of these synonymous phrases should not take away from like the strength of the sentiments, or the sentiment towards the preference of a movie, for example. But yeah, that was basically the idea, to go in and kind of replicate the experiment in a kind of naive way, as in if we had used other priming verbs in our in the original guidelines, basically.
I guess my reaction is that this all seems like psycholinguistics to me.
Well, I guess it kind of is.
That in the sense that if you hammer away at like, then you're going to get that's going to be activated in the mental lexicon, and if you have a diverse set of forms, then it's and even that the forms themselves are not a monomorphemic. It's going to just push things around, and yeah, you will debias. And I totally agree with what you're doing, makes sense. I just would characterize it all as an experiment in psycholinguistics.
Yeah, that is very interesting, and I'm sure like in other fields, this is a problem many people are like very aware of. And
well, psycholinguistics don't they see as a problem? They think it's fun.
Yeah, and I also really like your analog, Mark, to the like poll surveying literature, where it is very important that you like design your polls or like your surveys in a way that if it be political or not, that is as neutral as possible to like extract the what people really mean instead of what you want them to mean.
Oh yeah.
Okay, well, it's 10:59, so the next session starts in 1 minute.